S is the displacement. Unit of displacement or distance is meter. So Newton meter, you can write the unit of the work, but unit of the work, this Newton meter can be written as joule also. So unit of work is joule, SI unit. Unit of charge, SI unit of charge. I told you SI unit of charge Q, Coulomb. So Coulomb we will represent with C, joule we will represent with J, volts we will represent with V. What is V? V is the potential difference. V is the potential difference. What is W? W is the work done. What is Q? What is small q? Small q is the charge. Okay. So remember these things. SI unit of uh, potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. V is equal to W by Q. This formula we will use. Okay. So first we will solve this question. I think we have done this. We will solve now this question. So in this question, they are saying that in the first part, A part, they are saying that name a device that helps to measure the potential difference across a conductor. So we know that potential difference is measured by the voltmeter. So I told you na, potential difference is measured by the voltmeter. You can see here. Potential difference can be measured by a device known as the voltmeter. So if across a conductor or across anything you want to find the potential difference, so you will connect a voltmeter in parallel and you will get the potential difference. So answer will be voltmeter. Okay, and you can just add points here. Voltmeter is connected in parallel and you can draw that figure also. Now answer number B. They are saying that they are saying how much energy, they are saying how much energy is transferred by a 12 volt power supply to each coulomb of charge, to each coulomb of charge. So what is the meaning of each coulomb of charge? Means each coulomb means 1 coulomb. 1 coulomb of charge. Okay. So Q is given indirectly, 1 coulomb, and potential difference is of 12 volt is given. Transferred by a 12 volt power supply. So this 12 volt power supply I will tell you later. Okay. So this 12 volt is the potential difference of the power supply. Okay, like battery. We will discuss later. So how much energy is transferred by 12 volt power supply to each coulomb of a charge which it moves around the circuit. So we will discuss circuit, then I will tell you. Okay. So basically we want to find the energy. So we have this formula. Potential difference is equal to work done divided by the charge. So first calculate the work done. So potential difference value of V is 12. We will put here work done. We want to find charge is 1 coulomb. So what we will get? Work. We will get 12 into 1 means 12. And what is the unit as SI unit of work? Joule. So 12 joule of work you have to do, or the 12 joule of work this battery or the power supply have to do. And we know that the power supply is basically what? Power supply is basically the electrical energy. So basically this work done will be the electrical energy. Okay. So energy will be equal to 12 joule also. So in this question, the energy will be energy is equal to work done. that is equal to 12 of joule. Now same question of NCERT you can solve the same concept. They are saying how much energy is given to each coulomb of charge. Each coulomb of charge means 1 coulomb of charge. Each coulomb of charge means 1 coulomb of charge passing through a 6-volt battery. If this is given a 6-volt battery, so this 6-volt will be the potential difference. Okay, this will be the 6 volts. Okay, potential difference. Energy they are asking, so we will first find the work. So we know the formula: potential difference is equal to the work done divided by the charge. So potential difference is 6, worked is W, and charge is 1 coulomb. So what we will get work as 6 volt, 6 joule of work we will get. And I told you that the amount of work that this battery will do will be the amount of energy spent. Okay, so energy will be the work that we calculated. Energy is equal to work that is equal to 6 joule. Okay, now we will discuss what is electric current. Now we will discuss what is electric current. So basically the electric current is the flow of charge. For example, suppose this is a wire, this is any wire, okay, and this is one point of the wire. Suppose this is A point of the wire and this is the B point of the wire. Now this A point of the wire have the potential difference VA, and this B point of the wire have the potential, not the potential difference, this is the potential of point A of the wire, and VB, this is the potential of the point B of the wire. Okay, so now if I am saying the potential of point B, or you can say the potential of point A, if the potential of point A is greater than the potential of point B, means the A is at higher potential and B is at lower potential. So A is at higher potential and B lower potential. Lower potential. So always remember this point. Always remember this point. The charge always flow. I'm not talking about right now the current. I'm saying the charge always flow from higher potential to the lower potential. Okay. So basically the flow of charge in this wire will be in this direction. Flow of charge. Flow of charge will take place in this wire from point A to B, because the charge always flows from higher potential to the lower potential. So you can write here also. Charge flows, like you can say the water always flow from the larger height to the lower height. Okay, if you have suppose water, if suppose this is some surface and suppose here is the water, so this water will go like this, means from, this is suppose some surface here, and here is the water, this is the water. Okay, and this water will flow in this direction or in this direction, from maximum height to the minimum height, from flow, or from minimum height to the maximum height the water will flow. We know that water always flow from the maximum height to the minimum height until unless an external force or external work you have to do. Naturally the water will flow from maximum height to the minimum height. So in the same way the charge will always flow from higher potential to the lower potential. So charge flow from higher potential to lower. Okay. Now, why the charge is flowing here? Due to the potential difference. Okay, due to the potential difference between the point A and B, the charge is flowing. And now coming to the current. The flow of charge is known as the current. The charge flowing per unit time is known as the current. So current is the rate of flow of charge. Rate of flow of charge. And why the charge is flowing? Due to the potential difference. So you can say indirectly the current is due to the potential difference. Formula of the current, I will represent current with capital I. The current is given by the formula of to calculate the current. Current is equal to charge divided by time. Charge divided by time. Uh, can anyone tell me what is the formula for calculating speed? Aman, Hamna, Abdullah. Speed. There is a relation between speed, distance, and time.
Distance by time.
Yeah, right. Distance by time. So what is basically speed? Speed is rate of covering the distance. Speed is rate of covering the distance. Speed is equal to distance divided by time. Means how much fast you are covering the distance. That is speed. Means how fast you are covering the distance. That is speed basically. If you are covering more distance in less time, means your speed is greater. If you are covering uh, less distance in more time, means your speed is lesser. So accordingly, the current is, what is the current? Charge flowing per unit time, or you can say charge in time. So more will be the charge per unit time, more will be the current. So more amount of charge will flow in less time, there will be the more current. So what is current? Rate of flow of charge. And you should remember this formula. So charge we know I will represent with Q, small q, and time I will represent with T, and current I will represent with I. So there is one formula here that you have to remember, I is equal to Q by T. Now reason of the current is the potential difference and the flow of the charge. The flow of the charge is known as the current. And why there is a flow of the charge? Due to the potential difference. I can only say that, and current is only the rate of flow of charge. But this thing also you should know. So now there is another thing how to measure the current. Earlier we discussed the potential difference. So the potential difference is measured by the voltmeter. In the same way, there is a device to measure the current that is known as the ammeter. If you will go in your lab, then you will see there. This is the ammeter, and this ammeter is used to measure the current. Okay, ammeter is used to measure the current. Okay, and before that, what is the SI unit of current? SI unit of current. So unit we can calculate by ourselves. So from the formula you can calculate the unit. If you have a formula, you can calculate the unit. Suppose I do not know what is the unit of the current. Okay, then how I will calculate? So current is equal to the charge divided by time. So unit of charge is coulomb, and unit of time is second. So you can write the unit of uh, current is coulomb per second, and this coulomb per second is also named as ampere. This Ampere was the scientist, physicist, you can say. Ampere. So SI unit of current is ampere. Okay. Ampere was the scientist. Okay. So this Unit is on the name of the scientist. Ampere we will represent with capital A. Okay, so you can write how we measure the current. Current is measured by the ammeter. Current is measured by ammeter. And one more thing, remember, ammeter always connected in series. Ammeter always connected in. Okay, wait for 1 minute, all of you. Okay, so ammeter always connected in series. And how you will connect the ammeter? Suppose this is the wire, and in this wire there is a current flowing. This is a wire, suppose, and you want to measure what is the value of this current. So what you will do, you will connect the ammeter in series with this wire like this. You will connect the ammeter. Suppose this is the ammeter. So this is the ammeter, and this is the wire, and you have connected this ammeter in series with this wire, and the reading of the ammeter will tell you the value of the current. Suppose 5 ampere current, 6 ampere current, you will get here. Okay, on this circular scale. This is a scale here. This is a pointer. So this pointer and a scale will give you the reading of the current. So you can tell what is the amount of current flowing in the wire and flowing in any device. And one more thing, you are connecting this ammeter in series. So one more thing you should know, this ammeter should have low resistance, because if this ammeter will have low resistance, then more amount of current will flow in the ammeter. I will tell you uh, further that resistance is inversely proportional to the current. Means the more will be the resistance in the wire, less will be the current, or more will be the resistance of any device, less will be the current, less amount of current will flow in that device. So if the ammeter will have the less resistance, then more amount of current will flow in the ammeter. And what is the use of the ammeter? To measure the current. So if more amount of current will flow in the ammeter, so there will be no error in calculating or in measuring the current. So ammeter should have low resistance. Ammeter should have low resistance. Okay. So now you can note down, all of you. Note down. And when completed, ask me to scroll down.
Hello, completed? Aman? Hello?
Yes, completed.
Okay. If completed, then you can ask me to scroll down. So remember, this is a wire. This is some wire. And one end of the wire is at higher potential, another end of the wire is at lower potential. This is wire. Done, Aman and Hamna, completed?
Yes, sir.
Okay. When completed, please tell me, okay? And if you have any doubt, then you can ask me right now. Can anyone tell me why emitter should have low resistance? Aman? Hamna? Anyone? The emitter should have low resistance. If this will have the low resistance, then it will have the high current, means the more amount of current will pass through the emitter. And if the more amount of current will pass through the emitter, more amount of current of what? More amount of current of wire will pass through the emitter, and the more accurate will be the reading of the emitter. Completed? Aman and Hamna? Beta, please tell me.
Yes, sir. Done.
Hamna completed? Okay, now see here. again, if there is a potential difference, means higher potential, A has had a higher potential here and B is at a lower potential. So the charge will flow from higher potential to the lower. The charge will flow from higher potential to the lower potential. Okay. Okay. So when means after how much time this charge flow will stop through this wire? This flow of charge will stop when the potential of A and potential of B becomes equal. When the potential of A and the potential of B become equal, then the flow of charge will stop. So basically you can say the charge will flow until there is a potential difference between 2 points. Suppose you can take the examples of real life. So in real life example, you have laptops, mobile phones, and many other things also you have. So in real life, continuous flow of charge, there, but after a certain period of time, after the potential difference becomes zero. Okay, and the potential of A becomes potential of B, and the flow of charge will stop and the flow of current will stop. Flow of current, like you have a laptop right now, you are taking the class, there is a continuous flow, you are able to see the screen. Okay, now for that purpose, I means you can say that a potential difference, there should be a continuous potential difference there between 2 points of will be the continuous flow of current. Now for maintaining the potential difference, a cell or a battery is used. A cell or a battery is used to maintain the 2 points in the wire. Okay, so due to that the current flows continuously and the device will work continuously. Hello, Aman and Hamna.
Yes, sir.
Beta, why you are not responding? Are you getting my voice properly now?
Yeah, I'm getting.
It's fine now?
Yes.
Okay. So how to maintain a continuous flow of current? To connect a battery across the ends of the wire. Okay. So just please draw this diagram, and this battery you can just draw like this. Okay, you can just draw this battery like this. You can draw this figure like this. This is the bulb and this is the wire. Suppose this is the wire, and here the battery is connected like this. Okay, and this is a positive terminal, this is a negative terminal, and here a cell is connected. Okay, and this is a negative, this is a positive terminal, and this is the bulb, and the current is flowing like this. Okay, the current is flowing like this. Please note down this. Hamna, are you there in the meeting? Aman, are you writing?
Yes, sir. About to finish.
Wrote?
Yes, sir. Done.
Okay, so you can draw this figure like this, and after that you should write this statement. This statement you should write. The simplest way to maintain a potential difference between two ends of the conductor so as to get a continuous flow of current is to connect the conductor between terminals of a cell or battery. So write down this statement also.
Done, sir.
Okay. So I discussed this formula. Current is equal to charge divided by time. So on this formula, we will discuss one numerical. So this in this numerical, they are saying an electric bulb is there. An electric bulb draws a current of 0.25 ampere for 20 minutes, means in a bulb for 20 minutes, this much amount of current is flowing, this much amount of charge is, current is flowing. So calculate the amount of electric charge that flow through the circuit. So simply you have to apply the formula. Current is equal to charge flow divided by time. So in this question, this value is basically the value of current. Current is 0.25 ampere. This is the current. I is equal to 0.25 ampere and time is given as 20 minutes. 20 minutes time given. So we will convert the minutes into second. We'll convert these minutes into seconds. So we will multiply it with 60 because in 1 minute there are 60 seconds. So it will become 6 to the 12 and 00 seconds. So 1200 seconds will be there. So they are asking calculate the amount of electric charge, means they are asking a value of Q. So I is equal to Q upon T. We will use this formula. So what is I? Current is 0.25 ampere will be there, and charge we want to find, and time is 1200 seconds. So charge from here you can find 0.25 multiplied by 1200. So when you will multiply it na, so you will get basically what you have to do, this 0.25 na, you can write this is 0.25 now, just remove this point and write here 100. And when you will cancel this out, it will become 1 by 4. So basically this 0.25 is 1.4 multiplied by 1200. So when you will cancel this 1200 with 4, so it will become 4 3 is 12 and 0. The charge will be of 300 coulombs. So charge will be of 300 coulombs is flowing through the circuit. Understood? Aman, Hamna?
Yes, understood.
Okay. So write down.
Done, sir.
Okay. So now we will discuss what is the direction of the current. What is the direction of the electric current? So direction of the electric current is from positive, the flow of the positive charge. So in earlier days, means long time ago, you can say, when there was a discovery of the electricity, so it is assumed that there are two types of charges, positive charges and negative charges. But electron was not discovered at that time. they do not know anything about electron. But we know that in conductors, the electrons are responsible for the flow of current in conductors. In conductors, the negatively charged electrons are responsible for the flow of current in actual. But in earlier days, they say the flow of positive charge is the current, is the direction of the current. Means the direction of current means if the positive charge is moving like this. If there is a positive charge and this positive charge is moving in this direction. So you will say, if you can take a wire, suppose this is a wire, and in this wire, a positive charge is moving in this direction. So you will say the direction of the current in this wire is in this direction. This is the direction of the current. So this is the conventional direction of the current. Okay. Conventional means they had assumed that long time ago, when there was not when their electron was not discovered at that time. But in actual, what happens in actual? In conductors, when we were discussing the insulators and the conductor, I told you that the flow of the current is due to the presence of the free electrons. So due to the electrons, the current is flowing, and electrons is negatively charged. So in actual, what happens? Electron is a negative charge. If the electrons will flow in this direction, okay, if the electron will flow in this direction, then only there will be the current. But we have already taken the flow of positive charge as the direction of the current. Direction of the flow of positive charge is taken as the direction of the electric current, because earlier we have done all the calculation on this basis. Okay, so this is the conventional direction. Conventional direction of current. Okay, if the positive charge is moving in this direction, then the current will flow in this direction. Okay, and if the negative charge is moving in this direction, then the direction of the current will be in this direction, opposite to that of negative charge. Okay, so here you can say in actual, what happens? The electron, if suppose in conductors we have the electrons, and if the electron is flowing in this direction, so direction of the current should be also direction of the current is the flow of charge, and here is the charge. Here charge is the electron. Electron is moving in this direction, but we take the direction of the current in this direction. So I will discuss this topic once again, okay, in the next class. Okay, Aman?
Okay, sir.
Okay, now we will meet in the next class, Hamna and Aman. I will discuss the topic once again in the next class.
Okay, sir.
Okay.